Assalamualaikum and a very good day. I am Aina binti Baharom, GS64638, under Supervisor Dr. Siti Munirah Muhammad Fauzi. I will be presenting on proposal entitled Development of Diary-Pentadienone as Anti-Methicillin-Resistant Staphylococcus aureus Anti-MRSA Agent. The outline for this study are as follows. Introduction, research objectives, literature review, methodology, and Gantt chart. As an introduction, public health has been significantly impacted by bacterial infections that can be easily accessed into our body through routes including respiratory tract and skin. Bacterial infections can cause serious complications and life-threatening diseases through prolonged effect if not treated. Center for Disease Control and Prevention (CDC) also reported an estimation over 2 million ailments and 23,000 fatalities count annually were contributed by antibiotics-resistant pathogens, including methicillin-resistant Staphylococcus aureus (MRSA). Since MRSA exhibited resistance towards methicillin and vancomycin antibiotics, studies on diary-pentadienones have been investigated for its potent bioactivity. The problem statement of this study are as follows. Clinical uses of curcuminate have been constrained due to its weak pharmacokinetic characteristics. It led to the discovery of new drug development of diary-pentadienone as potential candidate for antibacterial properties with enhanced stability and effective binding. Risk of bacterial infections and antibiotics resistance have increased. Therefore, evaluation of antibacterial activity in diary-pentadienones as anti-MRSA agents will be performed against Staphylococcus aureus. Scope of research for the study consists of determination of potential binding interactions that are responsible for the antibacterial activity using a series of techniques, docking simulation by autodock, in silico studies, phase filtration and aggregator identification. Next, reaction synthesis and compound characterization of diaryl pentadienones using X-ray diffraction (XRD) analysis. Lastly, evaluation of bactericidal activity of anti-MRSA agents against Staphylococcus aureus strains by cell culture and inhibition of bactericidal activity. Research objectives for the study consist of to determine potential binding interactions that are responsible for antibacterial activity via docking simulation, to synthesize reactions and characterize diaryl pentadienones by using X-ray diffraction (XRD) analysis. And lastly, to evaluate the bactericidal activity of anti-MRSA agents against Staphylococcus aureus strains. For literature review, Gnanamani 2017 stated that Staphylococcus aureus is a gram-positive bacteria that causes widespread diseases including skin infection and pneumonia. It stained purple, exhibited properties including thicker peptidoglycan cell wall, spherical-shaped bacterium, and formed deep golden-colored colonies when cultured. These pathogens tend to accumulate on organs such as bones, lungs, and hearts, causing bacterial infections that will increase fatality rate. Schneider 2021 stated that microbial natural products contribute to the present antibiotics, making them an essential for drug development. A enormous number of bacterial isolates can be theoretically investigated for novel secondary metabolites. Therefore, by using the right scientific tools, capacity for biodiscovery should be concentrated on most promising sources for chemical novelty and bioactivity. Rahman 2012 stated that diary-pentadienone possess great potential for antibacterial activity. It has been synthesized using Kleisen-Schmidt condensation and Julia-Kozienski olefination, a combination of one-pot synthesis. Development of diary-pentadienone as potent anti-MRSA agents will be performed against Staphylococcus aureus. For methodology, material and instrumentations, chemicals will be purchased on Merck, Sigma Aldrich, and Thermo Fisher Scientific. Solvents will be dried and distilled for analysis. Organic solvents will be used for mixtures extraction to be dried and concentrated in vacuum. Reaction progress to be monitored by TLC, then purified using column chromatography. And NMR spectra will be captured and mass spectrum measurement will be done using GCMS. In silico studies, paints and aggregator filtration, physicochemical properties. For paints and physicochemical determination, diarrhea pentadienone structure will be drawn on camera ultra to be transformed into simplified molecular input line entry system SMAS format for physicochemical study, then converted into spatial data file SDF format for paints filtration. Lastly, molecule will be generated for potential aggregators identification. For molecular docking, compounds will be docked into protein active sites by autodock. The Lamarckian genetic algorithm LGA will be employed for docking analysis. Protein will undergo pre-treatment prior to docking study. And lastly, hydrogen atoms will be introduced. Protein-ligand interactions will be examined. Synthesis procedure for diarrhea pentadienone. Compound will be synthesized by Claisen-Schmidt condensation using substituted salicylaldehyde under potassium hydroxide catalysis. Acidification with acetic acid and recrystallization using solvent mixture will be performed. Then, aldehyde and allyl sulfone solution in THF will be cooled and potassium bis-trimethicillin will be added for 2 minutes. Resultant liquid will be agitated for 1 hour and saturated aqueous solution of ammonium chloride will be added. Mixture will be extracted with ethyl acetate, dried and filtered. And lastly, the residual purification will be done using column chromatography. For the X-ray structure determination, compound crystals will be grown via evaporation. Diarrhea pentadienone crystals will be mounted on fiber loop then cooled. X-ray determination will be performed on diffractometer using graphite monochromatic radiation. Then, the data will be processed for compound structure. For the bioactivity evaluation of diarrhea pentadienone on Staphylococcus aureus, diarrhea pentadienone will be screened for its antibacterial activity against S. aureus strains. The cell will be cultured and inhibition of bactericidal activity will be tested. Gantt chart is divided into two, project activities and project milestone. That is all from me. Thank you.